Okay, Honors Algebra 2. This should be Thursday the 23rd, and we're going to continue looking at our geometric sequences today. And by the way, welcome to Mr. Patterson's class. If you're watching this, I am Mr. Clendenin, and we're going to, again, continue our geometric sequence exploration, and we're going to look specifically today at how to write the general nth term rule for a geometric sequence. We know that it's a sub n equals the first term a sub 1 times r to the n minus 1 power. But we're going to look at coming up with that general formula for a sequence given information about that sequence in different ways. Like this first example here, we're given a specific term in line and we're told what we multiply by. So a big thing today is realizing when you're given a specific term in line, you're given two things. You're given the number that you see in your sequence, in this case an 8, and then you're given where you will see it at. You'll see it in the third position. Okay, so that is two different pieces of information. So let's just look at how things fit into our generic formula here of first term times r to the n minus 1. So of course we know our r value. It is 4, so I'll just fill these in one at a time here. So we know we would have a 4 in there for r. And then here's where our two pieces of information come in here. We know that we see an 8 in the third position. So that means we will see an 8 in the third position. So again, I always say to myself, how do I get to that 8? I start at the first term. I start multiplying by 4, but the question is, how many 4s do I multiply by? I multiply by 3 minus 1, or 2 of them, okay? So that gives me 8 equals first term times 4 squared, or 8 equals 16 times the first term. Divide by my 16, and I find out my first term is 1/2. Now to write our rule, let's go back up here and look. Realize we only need two things to write the rule. We need to know the first term in line. We've got that. And we need to know our r value. We were given that. So we can right now say that for the sequence that has a third term of 8 and an r value of 4, the nth term rule would be 1/2 times 4 to the n minus 1 power. That's an n. Let me redo that. Okay. Now, I know, and Mr. Patterson knows, that if you're told the third term is 8, we could kind of draw it out here and say that means we see an 8 right there in that third term. And then we know our r is 4, so we know we were timesing by 4 when we headed to the right. But what would we do if we headed to the left from 8? We would divide by 4, and you would get 2. Then you would divide by 4 from 2, and you could get your half that way. That's cheating. We don't want to do it that way. We want you to learn the ins and outs of this formula, so we want to see this work here. Okay, so we need to see this, so keep that in mind. All right, and that's how we can get our nth term rule for our sequence if we're given a specific number in line and the r value. Now the next example is a little more complicated. We're given two numbers in our list. We know that the third number is -20, and we know the sixth number is 160. But remember, each of those is two pieces of information. So let's start off with this third number equal to -20. What can we gather from just that? Well, remember here, a sub n equals first term times r to the n minus 1. Where would the -20 fit at in that formula? Well, it will go right there. It would be -20 equals our first term times r to the what power? Well, it would be 3 minus 1. So I would say to myself, when I see that the a to the third is -20, I would say, how do I get to -20? I start at the first term and I multiply by 2 r's, or r squared. Okay. Then I would do the same thing with this second piece of information, that the sixth term is 160. So I would say, how do I get to that 160? Well, I start at the first term and I multiply by r 6 minus 1 times. So I get 160 equals first term times r to the fifth. And we generate two equations. Now what we got to realize is both of these numbers, our negative 20 and our 160, they're in the same list. So what's that mean about these two a sub 1's? They're the same number. What about those r's? They are the same number because negative 20 and 160 is in the same list. So now we're going to take these two, and I'm going to go to a blank slide. We're going to take these two and we're going to treat it like a system of equations. Okay, so let's go here. Let me get a blank slide. Whoops. Here we go. All right, so we were sitting there with negative 20 equaled our first term times r squared, and we had 160 equaled our first term times r to the fifth. If we divide by our r, so here we'll divide by r squared on both sides, we get a representation for our first term. We would say our first term is whatever negative 20 divided by r squared is. Okay, we could do the same thing for our other equation, divide by r to the fifth. And we could say our first term can also be represented by 160 over r to the fifth. Now remember, the first term is the same. So what's that tell me? I guess it would be a transitive property. It tells me that negative 20 over r squared has to be the same as 160 over r to the fifth. And then I just cross multiply on these. So we would get negative 20 r to the fifth equals 160 r squared. And now I'm going to solve. So I'm going to move this over, I'm going to add it, and I'm going to come up here where I got more room. So we'll have 0 equals 160 r squared plus 20 r to the fifth. Factor out a GCF here of 20 r squared. And we would get 8 plus r cubed. Now remember what r is. R is what you multiply by. So whenever you start solving this and you take that 20r squared and you set it equal to 0, and eventually you'll get an answer of 0. But would that make sense? That would mean you are multiplying by 0. If we multiply by 0, then we got a whole bunch of zeros in our list. So that gets thrown away. That's extraneous. But the other part of it, 8 plus r cubed, we set that equal to 0. We get r cubed equals negative 8. R cubed equals negative 8. Not r squared. And then we would cube root both sides, and we find out that our r value is negative 2. So there's what we are multiplying by. Now remember, you need two things to write your equation. You need to know what you're multiplying by. We got it, negative 2. And we need to know what our first term in line is, what a sub 1 is. Well, we can take this negative 2, we can come back over here and we can plug in to either one of these. I'm going to go the easier one, the first one over there. It says my first term is negative 20 divided by r squared. I'm going to put my negative 2 in for my r squared. So that would be negative 20 divided by 4. That tells me my first number in line is negative 5. So now that I know that, then I can write my general term here, general nth term rule. It would be my nth term. How do I get to any number in the list? Well, now I know I got to start at negative 5, and then I got to start multiplying by some negative 2's, and I would multiply by n minus 1 of them. So I'm going to squeeze this in. There's our answer. There's our nth term rule for the sequence that has a third term of negative 20 and a sixth term of 160. Okay, so that's a tough one. Got a little bit of work to do on that one. All right, so give your homework a try. Let us know of any questions. And also your homework. Your homework, I know Mr. Patterson likes to put his homework in the video. There it is right there. So you can copy it off of this slide, or my kids, I'll have the homework attached. Okay, so there you go. Good luck, and we'll see you tomorrow.